Hey there, hello. In one of our previous videos, we showed 6 different ways on how to run an ordinary square cross-sectional regression in Excel. Now, if you are the type of person who wants to claim they know how to run a regression, then I feel like you should theoretically be able to pull it off in Excel. But in practice, I don't think you should be using Excel all that much. So at least I prefer to use another software called Stata. You can use anything really, like R and Python, but Stata is the software that I prefer to use. So I thought I would make a video here just showing how to do the same thing we did in the previous video, just in Excel, or sorry, just in Stata instead. So let's just start off here with the data set that we're going to work with. It's a bit of a Mickey Mouse data set. So it's going to again be cross-sectional and it's going to be ordinarily square. So we have two variables here. We have the x variable and we have the y variable. And just to provide some context here, when I am lecturing, I make my presentation slides with LaTeX. So I've been wondering, can I predict how many lines of LaTeX code there's going to be based on how many slides I'm going to make? So as an example here, in this case here, those 119 slides, behind that there was almost 4,000 lines of code, 3,987. So that's the data set. It is stored in Excel in our workbook, which is called, you can't actually see that because it's cropped out there, but the data set is called dataset_SimpleRegression. And the worksheet inside of the workbook, that's the name down here, is data_LaTeX. That's all we need to know. So let's jump over to Stata. Here it is. So here is an empty Stata window. So you could type all the code in here if you really wanted to, but I don't recommend it. You should be using the do file editor. And you can open it by clicking over here. Or you can type do edit, a single word. So if you do that, you will get up an open notepad looking window, but I have taken the liberty of already typing in the code. So I'm going to zoom in here a bit. So first order business is the clear all command. Now Stata is like a kitchen bench. If you're going to make dinner, you need to clean away all the mess, from your lunch. So clear all gets rid of everything. Next here, I write set more, perm, or set more off permanently. Stata will always stop what it's doing when it fills up the whole screen. And that is annoying if you have a loop, because then you need to click the spacebar repeatedly as the screen is filled up, but you want the loop to continue. Now people get scared by the word here permanently, but Stata doesn't mean it when it says permanently. So setting more off permanently is only permanent in the sense that it will be back on again if you close your Stata and open it up again. So don't be fooled there. Permanently is not particularly permanently. Next here, I want to change directory. CD, that's short for change directory. This is a command that you can also use on Windows in the command prompt and in the PowerShell. Stata is reusing the same type of commands. So in command prompt, in CMD, you can create like a new folder, for instance, by writing mkdir, so make directory for short, and there's the name. You can do the same thing here really if you want to. So all the same commands from the command prompt can be used in Stata. You can actually launch the PowerShell from Stata, just in case you didn't know that and you find that sort of things interesting to know, but now we know. So change directory, and here I have this hard-coded the folder where I stored my data set, the one we just looked at. Next order of business is to kind of import this data set into Excel. So you write import, then Excel, then using, and then the name of the dataset, which was just dataset_SimpleRegression. And then you need to specify what type of Excel document is it, because there are many different ones. You would have a different one if it was like with macros. Then it would be XLSM, I think. But the default one is XLSX. So if you don't know which one you have, you can just, like when you save your Excel document, you can just click Save As, and you'll see the different options. But this is the default. Next there, I write a comma, and then I come with some optional parameters. So I write sheet, and then parentheses and quotation mark, data underscore LaTeX. So that is the name of the worksheet within the workbook. First we had the workbook name, and then we had the worksheet name, which is within the workbook, because there will be several worksheets in every single workbook. So the default name will be like just sheet 1, I believe. If you create a new workbook, there's automatically a worksheet there called sheet 1. If you have it in English, if you have it in a different language, it would be the equivalent. So in Norwegian will be ark 1. So if you create another worksheet, then it will be like sheet 2, sheet 3, sheet 4, right? Next here, I write first row. And let's remove that and just show what happens. So we can select this and click Ctrl D. D for do. So something happened here, and we got some variables. And I can write bro, which is short for bros. And let's see, here is the data. So we got the data set into Stata, but there's a problem. Everything is red. And red means that what you have here is a string. So what has happened here is that in Excel, we use the first row here to kind of specify the name of the variables. So Stata has erroneously interpreted this as data. So now we have both, a string or like letters here, and we have numbers. So the whole thing is like regarded as like a string. You cannot have different types of data in one column here. So to fix this, we write first row. So first row means that the first row of the data is ignored and interpreted as the variable name instead. So let's rerun this, Ctrl D. And now you see it is no longer red, and the first row are numbers, and the name has been put up here properly as a name. Next, we're going to run our regression. And I've written a code here which will not only run the regression but also output the results back into Excel. But let's just go to the command line here and show how it can be done. Let's see, can I zoom in here? Yes, I think I can. There we go. So to run a regression, an ordinary least square regression list, you write regress, and then the name of the y variable, and then the name of the x variables. If you have more, you can just put in as many as you want. Then you can put in a comment here, and you can write robust, which will make the standard errors robust. Remember, you kind of assume in ordinary least square that the error terms, residual, is homoscedastic. That is pretty much never the case. So if you put robust, that will be why it's error correction, which will adjust the standard errors to reflect that your residuals are probably heteroscedastic rather than homoscedastic. So if you don't know what that means, you don't need to know that. You can no matter what, just write comma robust. So you don't actually have to type out the names here in Stata. You don't need to type out regress. You can just write reg, and robust you can just write r. So as long as the name is not ambiguous, you can shorten it as much as you want. So you could write regress fully out. You can remove one letter. You can remove one letter, and you can keep removing. But at some point it becomes ambiguous. And like re here could be several different things. So we need at least 3 letters here. It was the same thing when I wanted to write browse. I didn't type it out, I just spelled B-R-O, and that was sufficient. That was for Stata to understand what I'm talking about. So the y variable in this case is going to be the lines of code. I want to predict how many lines of code there's going to be based on knowing how many slides there are. So regress the y variable, lines of code, on the x variable, which is slides, and we're going to make the standard errors robust. And you can just click enter now, and there you go. That's it. We run a regression in Stata. It was super simple. Regress, y variable, x variables, comma, robust. That was all you needed to do. That's the end of the story. Here it is. Wow, amazing. But there's more. I have seen a lot of students, they run regressions. Students don't need help to understand how to run a regression usually. They can figure this out on their own because it's so simple. But usually they have many regressions. They have like maybe they have like 10, 12 regressions they want to run. And then they're sitting here, they're copy pasting like one number at a time, and they go to the Word document and paste it in, and it takes forever. Terrible. Like we can do better. So there are different commands here that will help you output the regression results. I can do it automatically. The problem is I don't like them. I don't want to talk about them because they don't have the flexibility that I'm looking for. Some of these output commands, they only work for specific type of regressions. It could work for cross-sectional regression, but then it doesn't work for panel data regression, for instance. And also, they don't give me the flexibility they want. Maybe they always output like certain numbers from these regression results, but I only want a subset of that or a different subset. So I like to make my own script. So I want to output this regression table results to Excel. And by default here, it gives me the coefficient, it gives me the standard error, t-statistics, p-value, and the lower and upper boundaries of this 95% confidence interval. But let's say that I'm not interested in that. I just want the coefficient, I want the t-statistic, I want the p-value, and I don't want the constant term. I only care about like the actual x variable. So how can we do that? How can we output this automatically? Now we could just copy this. That would be pretty fast for this this very small example. But what if we had many variables and we had many regressions? So let's make a script for that. Or actually already made it. Here it is. So I'm just going to explain it. So here we run the regression, regress, the y variable, and the x variable, comma, robust. The first thing I did here is I don't want to hard code the actual variable names. So instead, I put them up here at the top of the script. So in most softwares, if you want to create a variable that has the value of 2, you can just write x equals. Okay, let's see. I have my keyboard in the wrong language. There we go. I could just write x equals 2. This would not work in Stata. In Stata, let's see. So I could write x equals 2, and then in the command line, I could just write x, and then it will print out the value of x just being equal to 2. Like this would not work in Stata. So in Stata, we have to do something like this. Local x equals 2, and then display, and then in this brackets, let's see, sorry, like this. This is how you have to do it in Stata. Here you create an x variable, you need to put local first, and then when you want to output x, you can't just type x, you need to put in this different, I'm not even sure what to call it. There's 2 different types here of single quotation marks. Yeah, the curved one and then the straight one. Yeah, I should have thought of how to describe that with words, but sorry, I didn't. So that's how you do it. So first I make a variable called the yvar, and that's going to have the value of lines of code. So this is going to be the dependent variable, the left-hand side variable, the thing you're going to explain, right? The explanatory variable, or the explained variable. And then I have local xvars, and I call it xvars in plural because we can have more than one variable. We could have x2, x3, and so on and so forth. So then we come here, regress, this sloped single quotation mark, yvar, straight quotation mark, and the same for xvars. So we can run this. If I click Control D, you'll see that Stata did what it's supposed to do. Next here, I create a matrix called output, which contains all of the information that you see here on screen. So what's going on there? All of this data here is stored in 2 different lists, the return list and the e-return list. So for instance, let's look at the e-return list. And I misspelled that. If I click enter now, you see the information pops up here. Here is the information. That's the information that is extracted from this table. So for instance, the r squared, is specified up here. How do I extract that number? Well, it's hidden in the return list. Here it is. So that could write display. This is short for display, by the way, for display. And then we can reference the from the list r square. You see, then we got the number. So that's how that works. We also have something called the return list. In here we have the table, the R table. So if I write matrix list R table, then here we get like all of the information that is inside of the table. It is right here. So if I want to reference all of these numbers, like extract them, I need to extract them kind of from the R table, which is in the return list. So that was all to wrap your head around, but let's just keep going on there. So I create a matrix called output, which is just equal to this R table. It's difficult to extract things like specific subsamples from the R table, so I rename it to output, like it makes it easier. Next, I create like an empty matrix that's gonna contain like a subsample of the data from the R table. If I want all of the information from the R table, I just output like the entire R table immediately into Excel. But I want a subset of the information. So I create an empty matrix and then I start to populate it. So first order of business there is to create a matrix called result, and I use a function called J that creates an empty matrix with k columns, k rows, sorry, and then 3 columns, and for the time being it's going to be empty. Like all of the cells in this matrix are going to be empty. What is k? Well, k is the number of right-hand side variables, the number of regressors. So here, local k, and not an equal sign, but colon this time, word count, so count the number of words in the list here, xvars. So this here is going to create a variable named k for kilo, and it's going to be an integer, which is just counting how many words is in this x variable. In this case, it's just 1. If there were like 2 variables, it would be counting 1, 2. So that's how it works. So matrix, result, J, 1 row, 3 columns, no values so far. So if I write in here, matrix list, and we run this whole thing. Let's see, we forgot to put in the name. Here we go, we can run it. It here created a matrix with 1 row and 1, 2, 3 columns. And for now it has the default name like row 1 or R1 for row 1, C1 for column 1, C2 for column 2, and so forth. So that's how it works. One thing I forgot to mention about this like local variable name thing is that you can't define a variable and then use the variable later on. If you run a script, you need to define and use the variable like in the same snippet that's being run. So if I were to run local yvar independently, and then later on try to run the regression here, it wouldn't work. I need to select both of them at the same time and then run. That's the limitation here of local. It's a very strange peculiarity of Stata. I don't know why it is that way, but that's just how it is. You can use instead something called global. So you write like a global, then you can reference it whenever you want. So global instead of local. However, I would not recommend to do that for various reasons, which I will not go into right now. So, where were we? Next here, I want to create columns names. So creating column names for the matrix that's called result. And here I'm just hard coding. First column is going to be the coefficient. Then the second column is going to be t statistics. And then the third column is going to be the p value. So what we can do here is just to run it and then show how it works. So we need to run this whole thing. You see, we got this matrix again. This time, instead of it saying like C1, C2, C3, we now have actual names in there. So that is pretty nice. And then of course we also want the row names. So that's what we do next there. I'm gonna tokenize the list of x variables. So if you have a string that have like different words in it, you can reference like the first, second, third, and fourth word of that list of words, right? So that's what tokenize means. So to reference like the first word of this tokenized xvars, you will have to just write in 1. Then you get the first word, second word, the third word. So I make a 4-value loop here. So I'm looping from the integers 1, 2, 3, 4 all the way to the k number of variables. And k came from up here. We're just counting how many words there are in this list over here. In this case, it's just 1. So this loop is completely redundant because we're looping from I equals 1 all the way to I equals 1 again. So it's not a loop, it's just like one single iteration. So this script is needlessly complex right now for our simple example, but we have made this robust for the cases where we have many variables. Like we could have 5 variables and we could have more regression, that kind of things. So it's a bit needlessly complex right now. But we're looping through here and we create a variable called row n, so row name, and I'm going to populate it with different names of the independent variables. So right now it will just contain slides. But you could also have like slides, and then the second variable, the third variable, the fourth variable. And then all I have to do, so matrix, row names, result equals this which we created here through a loop. I hope this is understandable, but we'll see. So let us just run this and see what happens. Now we get this matrix again, we have the column names already, and this time rather than saying R1, it now says slides, which is the name of the X variable. So that was a lot of work just to create this matrix. So next we're going to do here is to start to populate the matrix with values from this R table matrix, which we called for output. So we create another 4-value loop here. So from values I equals 1 all the way to k, which is still 1. Let's see, and here we have a piece of redundant code. This shouldn't be here, sorry. I decided to move it up there instead, just to make it more easily understandable. So these two loops could be put together, but just for to be more pedagogical and easy to explain, I separated them. So for one particular right-hand side variables, I want to extract 3 different things. I want to extract the coefficient, I want to extract the t-statistic, and I want to extract the p-value. And I want to put it inside of this table right here. So if I write matrix list our table, this is where we get the data from. Let's see. Hold on a second there. So this requires some explanation. So matrix result row, comma 1. So row is just going to have the value of 1 here. It's just like one single variable, so it's always going to be equal to 1. So in position 1, 1, that will be the first row, first column. That's going to be over here in the result matrix. That's the matrix with the subset of information. So in this position, we are going to extract from the output matrix, which is the R table over here, from 1, I, which is also going to be equal to 1 in this first iteration at least. So first row, first column in output, or in, sorry, I mixed the names there myself, in result, is going to be 1, 1 over here. So putting this number, 29.8, over there. And then here in matrix result 1, 2, that's going to be the first row, the second column here in my result matrix. I'm going to extract from the R table, that's going to be 3, 1, so that's over here. I'm extracting 3, 1, row 3, column 1, which is t-statistics 14.16, and putting it up there. And then finally, I want to extract 4, 1, that's over here, that's a p-value, so row 4, column 1, and put it over here, row 1, column 3. So see, I'm taking specific numbers up here and putting them inside over here. That's what's going on here. So I can decide whatever I want to put in here. I can put as much information or as little information I want. It's up to me. This gives me perfect amount of flexibility to do whatever I want. And then finally here, what we do is to export this. So let's just run this first and demonstrate what happens. So we create the matrix. Let's see, up here, we can run all of it. You see, here is the matrix. We have now actually put the numbers inside of it. The coefficient, the t-statistics, and the p-value. Now we only have to put this over into Excel. So we can use a command called putExcel. So first I create a variable called file name, which is going to be the name of the Excel spreadsheet I'm going to create and then place this table into. PutExcel set the file name with the optional parameter of modify. We could put replace there, for instance. We just want to update the spreadsheet every single time rather than replace it. You can decide if you want to modify or replace it. And finally here, putExcel, and in cell D5 inside of this spreadsheet, which is called regression results, we're going to put this whole matrix, the matrix over here, and we're going to also put in the names. That's the column names and the row names. So let's just run all of that. And then we can open up Excel. Let's see, it's on the other screen there, you can see it yet. Let's see if I can open it. Here it is. So it got outputted into Excel. Here we have it. It was in Stata, now it is in Excel. And the name, this document was created by the Stata code. It's called regression results. And we have the matrix. So that's all there is to it. Hey there, Future Sindr here. While I was editing the video, I noticed I made a mistake in the script, so let's just fix that real quick. So here is the loop, and I think I changed my mind while I was writing it. We don't need the local row 1, we can delete that. And instead of saying row, we just say I. There we go, now it works. And I also put in an additional example here with more variables. So here we have a generic y variable and then x1, x2, x3. This is just randomly generated. So we can run this now and see what happens. So we can highlight this part and Control D. And here we get the regression output table, or the one we have selected list, the subsample. So we can now open up the Excel spreadsheet. Here we go. So here's an example where we have 3 variables instead of just 1 variable. So the final thing I'm going to do is just to slowly scroll through this script. Let's see, we can. There we go. So get rid of everything else, set more off, change working directory, get the data, define the variables, run the regression, make this matrix with the R table output, count how many variables there are and make this empty matrix. We put in some column names in this empty matrix. We put in the row names in this empty matrix. And then we start populating the empty matrix with values from this R table matrix. And then we are outputting it with putExcel. And this line we don't need anymore. And then finally, we are just showing it in the Stata output window. So that's the whole script. This is how it looks. So that's it. Bye.